you can already see what the difficulty is. The interaction of the cat with the photon, then Bob with the cat getting entangled to the photon, all of this has to be undone, let alone if you think that the cat dies in one branch, if it sees a photon going there. That means the cat has to be revived and has to be alive at the end of the experiment. A friend of mine calls this operation the Lazarus operator. So it has to bring the cat from the dead. So that's why, there's no point in really talking more about this, because it may simply be completely inconceivable. But the bottom line is that, logically speaking, we are talking about simply 3 quantum bits worth of experiment. You need 1 quantum bit for the photon, another quantum bit for Bob, and yet another quantum bit for Alice. So logically speaking, it's an extremely simple experiment, providing that you can control it very well. And in fact, coming back to David's point, it may well be that we don't need more than 1,000 fully coherent quantum bits to simulate a conscious entity. We don't know that. I mean, this is all wide open. So I'm not even going to speculate about it. I have no idea. But maybe you can do the whole thing with a computer that simulates artificial intelligence. And all it takes is 1,001 atoms to perform exactly this experiment, and you will confirm all of this. So there's no point in us speculating which way this would go. Is it possible or impossible? I think everything we've done so far suggests to us that one day this may well be possible. We don't know. We have to keep going in that direction. So now, halfway through the experiment, what's interesting is that Alice can confirm that Bob is entangled to the cat, to the poison, to the photon. All of them are entangled. They're in this highly entangled state. Topologically speaking, this is something that we call Borromean ring. Each of these links is connected with the other link until you erase one of them, and then they all fall apart. They are no longer entangled. This is something that we call a GHZ state, or Wigner's friend. And so it's very interesting that Alice can actually confirm a superposed state without collapsing it, without entering that entangled state. And let me add yet another twist on the tail. She can even communicate this to Bob now. So halfway through the experiment, when Alice sees that Bob said yes, in both of these branches, Bob sees a definitive state. She can now write subsequently on a piece of paper. She can say, I know, dear Bob, that you see a definitive state, but let me tell you that there is another branch in which a copy of you exists that sees the other outcome. This is exactly the unobserved outcome that can affect future measurements. And that's actually what Tony had in mind. And that's the way it is if quantum mechanics holds at this level. So here is Alice telling Bob that he really is in an entangled state, even though to him, it doesn't feel like an entangled state at all. So if you didn't tell Bob that he's in an entangled state, and you ask Bob to predict what's going to happen when he goes through the final beam splitter, in each branch, Bob would say, I'm going to end up statistically 50-50 at each of the outputs of the final beam splitter. But that's not what's going to happen here. He's only going to come out one way, the way he came in, if quantum mechanics is correct. And the only way that Bob can predict this is if he knows that he is in this superposed state. So when Alice tells him now that he is in both branches, he will be able to conclude correctly about future experiments. Otherwise, he gets surprised. It's very interesting. So let me not dwell too much on these things, but for those of you who are not familiar with the logic of this experiment, why you can do this, it's effectively a parity check. What Alice needs to do to confirm that Bob is in an entangled state is basically equivalent to a controlled swap gate in quantum. That's why I said you can do it with 3 qubits. 1 qubit is the control qubit, and the other 2 qubits are Bob and the photon. if you like, or Bob together with the cat, or cat together with the photon. It doesn't matter how you partition this. And actually, it's the same logically as this classical riddle of having two brothers, which are correlated in the way that one always lies and the other one always tells the truth, but you don't know which one is which. And what you have to extract from them is a certain true statement, but you cannot know which of them is a liar and which of them is a truth teller. So, and there is a way of doing that, but you have to ask a question which correlates the two outcomes. And this classical gate, the quantum equivalent of this classical gate, is exactly what Alice needs to do to confirm that Bob is in an entangled state. That's kind of the logic of that. It's just a quantum logic in this case. And of course, needless to say, there could be yet another. I'm continuing with the Alice in Wonderland analogy. There's Mad Hatter. There could be other observers, and each of these observers will have their own perspective, as Tony said. Each of them will have their own clocks, their own spaces, times, all of that, and none of that is ever in contradiction with quantum mechanics. In fact, that is exactly the message of quantum mechanics. That's what's interesting. We just need to be able to test it at a more and more macroscopic level. And now the final thing along these lines is the following one. So then I will make a few comments, and I think I will wrap it up. Hopefully I'm on time. The final thing, and this is what sometimes people think it's a puzzle, but again, I just want to say it's not a puzzle at all, is that Alice, and I don't think this should come as a surprise to you, Alice can, even if she can control Bob, she can convince Bob that quantum mechanics is completely wrong, actually. And so let me give you that scenario. That also is a consequence of quantum mechanics. Now I'm going to use quantum mechanics to prove that quantum mechanics is wrong. And I'm claiming there is no contradiction in what I'm going to do now. So Alice gives Bob n qubits, n is a large number, all prepared in an equal superposition of 0 and 1. Each qubit is identical and prepared in an independent from others superposition, 0 plus 1. And then Bob is told to measure each of them individually in the 0-1 basis. And now, if we are right that quantum mechanics holds at the level of Bob as well, there will be 2 to the power of n Bobs in each of the 2 to the power of n universes, each labeled by one of the 2 to the power of n strings that actually corresponds to the outcome of measurements. There will be a universe with all zeros, and Bob will be looking shocked there. It's like tossing a coin and getting 100 tails, and someone told you it's a fair coin. And there will be all other universes. Majority of them obviously will be the typical ones, as we call them statistically. But Alice, remember, Alice controls the whole experiment. I'm assuming Alice can apply any unitary transformation. And in this case, Alice will do what we call amplitude amplification. Alice will simply run something akin to Grover's search algorithm that will amplify the branch which contains all 0 outcomes. And that's it. That's the only branch in which Bob now exists with 100% probability. So Bob comes out of the laboratory and he said, "Gosh, Alice, I violated quantum mechanics. They all came out in a state 0, and you told me you gave me an equal superposition of n of them." And that's it. That is the conclusion. There is no other punchline here. Anything is possible if Alice has this kind of control. And like I said, you know, it may be a long time before we are able to do this with a conscious human observer. But actually doing this with a quantum computer with 1,000 quantum bits is a reality already. That's exactly how this goes. We know we can do these things with near certainty. So now between 1,000 qubits quantum computer and a human being is anything dramatic. going to happen that forces us to abandon quantum mechanics? I have no idea. But I think whatever comes next, I think something will come next. But I think it's going to be even weirder than quantum. It's not going to be a return to classical probabilities and correlations and all of that. Anyhow, this is so, by the way, the same is true classically. If the world was completely classical, and if Alice has the power to re-engineer your brain whichever way she wants, then she can convince you of anything she likes. So there is nothing peculiarly quantum about this. All I'm assuming is that I have a power to really deterministically control a large part of the universe. There's nothing contradictory about this. Anyhow, when people talk about Wigner's friends, this is only a tiny, this is the Mott scattering, the alpha particle scattering picture that I gave you. This is only a tiny, tiny aspect of quantum mechanics in which we have orthogonal branches that we can clearly identify. Each of them we can think of as a classical world, and all together they exist in a superposition. But this is just one approximation. Of course, we, being macroscopic and through our perception, seem to see the world in this way. But of course, all our microscopic experiments are telling us that the universe is very different, and possibly even at the macroscopic level. So Wigner's friend is just one of those very special GHZ-like states, but quantum mechanics applies to any other states in between that are non-orthogonal and everything else, just like in the alpha particle scattering.